So very good day to everybody. This is using Python in multimedia and gaming machines, and in today's class we discuss about GIF, graphic interchange format, coding standards, and about JPEG, Joint Photographic Experts Group. Okay, so that standard we'll be discussing, and about especially about JPEG 2000. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we discuss about GIF file format. So how the decoder program will know that the particular file is a GIF. Okay. So then we'll discuss about signature, about the color table information. Okay, then we discuss about JPEG 2000. Okay, so we'll discuss about its application specifically in the CCTV security, JPEG 2000, and of course MPEG compression. Okay, then how you try to distribute this particular image in the internet. Okay, then we discuss about JPEG 2000 code stream, about PCRC, and of course context modeling, the JPEG 2000 bit stream as well. Okay, so I've already given the invariant work in the HEMS. Okay, please complete them as soon as possible, and at regular intervals I'll be giving you some short videos to discuss the knowledge in our topics. Right, so this is GIF. Okay, so it's graphic interchange format. It's actually a BMP, bitmap image, that you can use it everywhere in the www. What is www? World Wide Web. Okay, so because of its huge support and of course portability between the applications and the OS, that the GIF is normally used. Normally, if you have some animation, for example, one particular video, it will be looping again and again. Okay, like for example, I throw some box. Okay, like that, it tries to repeat. Okay, so the format is supporting up to 8 bits per pixel for each of the image, and it will be allowing a single image to reference its own palette of up to 256 different colors chosen from 24-bit RGB color space, so red, green, and blue. Okay, so you can support animation, and of course you can have a separate palette of up to 256 colors for each of the frame that you'll be using. So the palette limitations also makes this GIF much less suitable for reproducing color photographs and of course other images with color gradients even, but definitely it must be much suitable for simpler images, maybe like graphics, logos with solid areas of color. Okay. So graphic images, now this GIF images are actually compressed using LZW, Lempel Zip Welsh, lossless data compression technique, in order to reduce the particular file size without degrading the visual quality. For example, the animation you choose. For example, I send one message, please everybody complete this Jori Nazar in the HEMS. Then immediately you put some GIF. Okay, thank you, like some image or maybe handshake symbol, so that it will be looping again and again. Even if you see the file size, it will be very less. The quality is also not disturbed. Okay, so even we try to practice this GIF with the 256 colors. Okay, so we'll try to understand the situation. Why isn't a GIF with 129 colors smaller than one with 256 colors? It's just because the number of entries in the color table is not directly stored within the GIF file. It is actually calculated from the number of bits which are used to represent each index in the table. Okay, so here the total number of entries in the color table is actually calculated by raising 2 to the power of number of bits per entry. So which means that if the number of bits used per index is actually 8, there will be maximum of 256 entries in the color table. Okay, right. So this is how it will go. Okay. So even like we'll have this number of bits used per index is actually 8. So that is actually 2 power 8. Okay, 2 power 5 is 32. 32 multiplied by 2, 64. 64 multiplied by 2, 128. 128 multiplied by 2, 256. So this 129 color palette will be requiring 8 bits per entry, okay, because 2 power 7 is equal to 128, which means that 256 color palette will be allocated even if only 129 colors are used. So that is by default, okay. And of course, can a multi-image GIF have more than one transparent color? Of course, yes. Because every image in the multi-image sequence will be having its own local color palette, which means that it has its own transparent color index. Okay. So the transparent index for this color table, you can call it as the graphics control extension. Okay, so according to this implementation, only one graphic control block is actually allowed per image. So every image has its own unique transparent color. Okay, so and the maximum color depth of the GIF file is actually 256 colors. You can use elec alter. Okay, so that much colors you have, because every pixel is represented by the single byte. Okay, so which will be acting as an index for each of the colors, like 2 power 8 equal to 256 colors. So here the first 3 bytes of this GIF file, you'll be having like hexadecimal format 0x47, 0x49, 0x46. So that is actually the string GIF in the ASCII characters. Okay, bytes 4 to 6 are nothing but hexadecimal, hex string. 0x38, 0x37, 0x61, or maybe it can be 0x38, 0x39. In place of this 0x37, you'll be having 0x39, 0x61. It can be either 87A or maybe 89A in the ASCII format, depending on the version that you are trying to use. But unfortunately, some applications, maybe some web browsers, determine the content of the file solely used by the extension used on the file name. Okay, so maybe whether we can make the smallest possible multi-image file, but definitely you cannot particularly answer to this particular question, because one way to make sure that the image manipulation software that you are trying to use is using the global palette. So if it is getting access to global palette, then definitely you can use them. Okay, so that is how you are going to share the color tables. Okay, so every image may have its own local palette, which may be for the 256 color palette, it can add 768 bytes per palette. Okay. But definitely, like every bit will be counting. So the GIF format will be providing an offset, okay, which enables you to choose a disposal method for each image in the file. So here the size of the file can be reduced by removing the redundant data. Either you can create a bounding box around the change area, and maybe you can crop the rest of them. Okay, or you can analyze the image on a pixel by pixel basis, and maybe you are going to set the unchanged pixels to the transparent format. Okay, and maybe you can allow the underlying frames to show through. Okay, so GIF file format is pretty much easy to decode. Okay, so the specification is not the best general purpose file format description as well. So for example, if this format of each type of the block is actually inconsistent, which makes it much more harder to understand. Okay, so here the standard unit for the fields that are used in the GIF file is actually the byte. So though in several cases, like GIF will be using packed data structure. Okay, so that's the byte structure that you will be using in order to store the multiple fields within that particular single byte. Okay, so because these of these structural decisions that we will make, GIF does not have much room in order to grow as a particular file format. But definitely it is fine. Okay, it's reliable, very robust specification with the GIF. Okay, even like Composer, so that has recognized PNG as the official successor to GIF. So that's the successor. Okay, so there will not be any more official GIF revisions. Okay, so that's what has come up with Composer. Okay, so GIF file always starts with a 3-byte signature. Okay, GIF, okay, and ends with the byte hexadecimal format 3B. Okay, so that is going to indicate the end of the data stream. So there is no built-in error checking for determining whether the data has been corrupted or not. Okay, but signature is the part of this header block of information. Then you will have header block. So the header block will be containing signature that identifies it as a GIF, the version 87A or maybe 89A, and maybe a logical screen descriptive block. Okay, so that will be containing information about the minimum requirements of the device needed to display the image as intended by the creator. Okay, so the header will be containing information about the global color table that is actually included in the file, and the header that is actually 13 bytes in length will be having signature that is actually 3 bytes. It will be having always the GIF. Then the version, it is also 3 bytes, and it's always like 87A or maybe 89A. Okay. So the color table information will be having screen width and screen height. Screen width 2 bytes, screen height 2 bytes. Okay. So the minimum screen dimensions that is actually required on the display device to actually render the image without scaling to fit the screen. Okay. So these are actually used for general purpose images. Then you'll have color table information. It is 1 byte. So the next byte is going to describe the attributes of the global color table, and here the 8 bits in this particular color table will be as per the following fields. For example, bit 0 to 2, okay, it will be like the number of bits which is used for each of the color table entry minus 1. Okay, so if the color table has 256 entries, means every entry would be requiring a 8-bit index, so the field will be containing only 7. So in the binary, if you can see, binary value for 7 is actually 1, 1, 1. Okay, and this number will be calculating the number of entries in the color table. Then you will have bit 3 that is actually set to 1 if the elements in the table are sorted, okay, in order of decreasing the occurrence in the image. Then you will have bit 4 to 6, okay, so that's the number from from 7, okay, so that is indicating the significant bits per sample of each color in the table minus 1. Then finally bit 7, the global color table flag, which is actually 1, okay, if the file contains a global color table. Okay. Then finally the background color, so that's also 1 byte, okay, so that will be containing the index for the color in the global color table that will be used as the border and maybe the background colors for the file. Okay. So the version of JPEG, okay, we will be having JPEG 2000. Okay, so that's the standard which is actually finalized in ICA Ming Bir. Okay, so that time only it was actually established. Okay, so that is defining a new image coding scheme. So that is using the state-of-art compression techniques based on the wavelet transform or maybe wavelet technology. So here you can use it in several applications, maybe like internet image distribution, security systems, digital photography, and maybe medical imaging. Okay. So here we'll be having several applications, like we are going to compare with several standards like MPEG, Moving Photographic Experts Group, or maybe Moving Picture Experts Group 2, okay, that's version 2, MPEG 4, or maybe earlier JPEG. Okay. So maybe you can use this JPEG 2000, okay, like digital still images, okay, HD or maybe SD, high definition or maybe standard definition, video production, CCTV security, internet, and office automation. Okay, so in digital images like military, HD satellite images, high quality transmission, high quality storage, remote sensing, you can use them. Industrial, for high quality storage you can use them, and remote sensing as well. And even medical field, you can go for high quality storage and high quality image processing as well. Consumers, like in the mobile phones that you can use, or maybe Palm Pilots, you can use them. For the high definition or maybe standard deviation, standard definition video production as well. For professional camcorder or maybe HDTV video editing as well. Digital cinema, you can use them. Consumer, even HD camcorder or maybe digital cinema, you can use them. CCTV security for motion detection, okay, to detect the motion. Network distribution, storage, you can use them. For internet, for larger image databases, streaming the video, for example, like football match you are seeing, that you can use them. Video servers, you can use them. Office automation for copier, network scanners, servers, you can use them. So this is the application in the CCTV security. So whenever you are going to transmit or maybe store the picture information, compression is very important in order to maintain the picture resolution whenever you are going with a limited channel bandwidth. So compression here is defined as lossless if full recovery of the original is actually available from the channel without any particular loss of information. Otherwise, it will be termed or will be determined lossy. Okay, so here the standards are actually required to ensure the interoperability, and JPEG 2000 is the only compression scheme which is going to provide both lossless as well as lossy compression. So there are several applications in the high quality images as well, despite the limitations on the storage or maybe the transmission bandwidths. Okay, so one particular the application of JPEG 2000 is the ability to extract several variety of resolutions, several variety of components, areas of interest, compression ratios that might range from the single JPEG 2000 code stream. Okay, so this is actually not possible with any other compression standard, because image size, bit rate, and of course quality must be specified on the encode side and cannot be determined or be changed on the decode side. Okay. Then you'll have this JPEG 2000 and MPEG compression. So for example, like a CCTV, closed circuit TV security system, makes use of this feature by actually sending the single JPEG 2000 code stream over the lower bandwidth network. Okay, so higher resolution images can be actually stored on the hard disk drive, while the several lower resolution images are actually displayed on the monitors. So here the operator on the receiver side can actually decide what information to extract from the single code stream which is actually sent. Okay, so JPEG 2000 is actually frame accurate, which means that every single frame of the input is actually contained in the compressed format. So here the MPEG systems will be reducing the amount of data through the temporal compression. Okay, so the MPEG compression is not actually frame accurate. So for these reasons, like legal issues will be restricting the use of MPEG compression in security applications. So maybe in order to go around this problem, the security system and of course the equipment providers, okay, have to develop their own compression schemes, okay, or maybe use this highly inefficient MPEG, motion JPEG compression standard, in order to provide a compression stream that contains every single field of the original. Okay, so you can use like JPEG 2000 for newer designs as well. For example, here if you can see original, then you'll have the mathematically lossless compression 2:1, then mathematically lossless decompression. Okay, then here also if you can see the original, okay, visually lossless compression 5:1 aspect ratio, lossy compression 50:1 aspect ratio. Then in the internet also, when you try to distribute this one, it should be of good quality. So this is the way we'll go for progressive coding. So that's another feature of JPEG 2000. So which means that the bit stream can be coded in such a way that it contains less detailed information at the beginning of the stream and maybe more detailed information as the stream is going to progress. So it's much more easier, much more ideal for the internet or maybe network application, especially if the images are larger images and maybe lower bandwidth. Okay, so the images can be seen instantly on the decoding side, even with lower speed networks or maybe image databases. So here the lower couplings are actually shown first and maybe more detail is actually added as time is going to progress. So the image or maybe the picture becomes much more sharper and more detailed over time, and the entire image does not have to be downloaded before it is seen. Even like WhatsApp, you can see the image, you are actually not downloading, you are actually seeing them. Okay, so this is how you are actually distributing the image in the internet without degrading the quality, and of course you are getting the original characteristic. So with the low quality image instantly available, so the user at the receiving end can actually decide whether to view the picture in its fully decoded version or maybe to pass it and maybe scan the next picture instead. So clients also can view the images at different resolutions or maybe different quality levels or maybe compression rates, making them suitable for any transmission bandwidth or maybe connection speed or maybe display device. So in addition, the JPEG 2000 coding, okay, will be providing the option to actually zoom in or maybe zoom out on a particular area of the image, or maybe to display a particular region of the image at a different resolution or maybe a different compression rate. So then we'll have the code stream. Okay, so the given input image or maybe some part of the image, you can call it as a tile, that is actually sent to the set of the wavelet filters. So which is this way, here it is going to transform the pixel information into the wavelet coefficients, which are actually grouped into several subbands. So every subband will be containing the wavelet coefficients that will be describing a specific horizontal as well as vertical spatial frequency range of the entire original image. So which means that the lower frequency, lesser detailed information is actually contained in the first transform level, while more detailed, higher frequency information is contained in the higher transform levels. So for simplicity, we will be having two levels of transform. So the first transform level results in the subbands LH1, HH1, HL1 and LL1. So lower, higher, 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 lower, lower, lower. Okay. So only the subband lower, lower one is passed on for further filtering, generating the next transform level and maybe creating further subbands like LH2, HH2, HL2 and LL2. Then we have post compression rate control, PCRC. So here equally sized code blocks, which are essentially bit streams of data, are actually generated within each subband. So here the breakdown is actually necessary for this coefficient modeling and of course coding, and it is actually done by the code block by code block basis. So here the actual compression is actually achieved by actually truncating or maybe requantizing, okay, requantizing the bit streams which is actually contained in each code block. So here the bit streams are actually optimally truncated using PCRC, post compression rate control. Okay, so here the code blocks can be accessed independently and the bit streams are actually coded with 3 coding passes, okay, per bit plane. So this process you can call it as a context modeling that is going to assign information about the importance of each individual coefficient bit. So this code blocks can then be grouped even according to their significance. On the decoding, it's much more possible to actually extract the information according to the significance, which allows the more significant information to be seen first. So JPEG 2000 can contain a user-defined number of layers which are actually defined by this PCRC and of course context modeling. Okay, so every layer will be having its own compression rate, where the compression rate is actually achieved from the quantization, rate distortion and of course context modeling processes. Okay, so here layer 0, okay, contains the bit streams from the lossy wavelet transform. So that is actually heavily truncated. It will be containing no coding passes and of course provide the highest compression rate and the lowest quality. So here we'll be having encode type image over the wavelet transform into the subbands and resolution. So here like we'll be having several layers. Okay, so layer 16 can contain the bit streams which are lesser truncated, okay, lesser truncated, and uses the higher number of coding passes which will be providing lower compression without degrading the quality. Finally, the JPEG 2000 bit stream. So here the tiles or maybe images are further partitioned into precincts. Okay, so the precincts will be having like the number of code blocks, and maybe you are going to facilitate access to the specific area within the image in order to process the area in the different way, or maybe to decode only a specific area of the image. So here the JPEG 2000 bit stream is actually generated by arranging the code blocks or maybe the precincts into an array of packets with the lower subbands coming first. So here the JPEG 2000 code stream will be starting with the main header containing the information like uncompressed image size, tile size, number of components, bit depth of the components, coding style, transform levels, progression order, number of layers, code block size, wavelet filter type, quantization level, and so on. So here also like image data, it is grouped into code blocks. lower, lower, higher, lower, lower, higher, higher, higher. Okay, LL, HL, LH, HH subbands following the header. So here data is actually not contained in the header information. Also, like table of contents is actually stored on the encode side, which allows the decoder to call up certain resolution on demand without first having to decode or maybe download the entire JPEG 2000 code stream as well. So here we will be just like encode, we will be having decode. One JPEG 2000 stream is received by several decoders. Okay, right, over the layers. So here if you can see decode one higher HDD recorder. Okay, so it's going to request the full resolution lossless, all components pressing 0, packet 0. So here decoder to high quality printer request full resolution lossless all components. Then decoder 3 CCTV display. Okay, so this is how you display, request small resolution lossy type Y component only. So that is how, depending on the characteristics of several decoders.